in June this year, the United Nations Food and Agricultural Organization (FAO) reported that 52 out of 63 provinces in Vietnam are affected by drought. 18 of these provinces were declared states of emergencies. The Vietnamese government, with assistance of the FAO, is scrambling to import food into the country to be able to feed the millions of people living in rural areas. With recent deterioration in the climate, governments in Asia as well as across the world are preparing better supply chains to ensure there is enough food for when a drought hits. But preparatory measures like these can only be stopgap measures. Introducing the D-Train, a constellation of 4 satellites that is able to bring rain to drought-hit areas. Using machine learning, we also aim to be able to predict where droughts are about to happen and seed rain to prevent drought. The picture here is of the A-Train, an existing constellation of which our design is modeled after. The D-Train has 4 satellites in its constellation. 3 of these satellites are sensing satellites and provide weather data to identify areas of drought. The 4th satellite provides orbital cloud seeding technology. The first sensor satellite, Soil Moisture Active Passive or SMAP, is an existing satellite launched in January 2015 and operated by NASA. It measures moisture in the top 5 cm of soil, creating high-resolution maps of soil moisture. This data is vital in determining if an area needs rain. The next 2 sensor satellites of the D-Train is the Visible and Infrared Observatory pair. It is 2 CubeSat-sized satellites. One satellite is a camera working in the visible spectrum while the other uses the infrared spectrum to get temperature data of the atmosphere. Next, the most important part of the D-Train is the Rainmaker. Starting in 2010, experiments by a group of Swiss scientists have been able to induce condensation with a laser. The technique is extremely complicated and is explained fully in the report. In short, it is possible to put a laser on a satellite to create an orbiting cloud seeder with more research on the technology. The laser will require 30 kilowatts of power, which is possible on a satellite with 75 square meters of solar panels coupled with supercapacitors. In regards to the orbital configuration, all 4 satellites orbit in the same sun-synchronous orbit at about 700 kilometers, with an orbital period of 100 minutes and an inclination of 98 degrees. This is the ideal orbit for the constellation. The existing satellite SMAP is already in a similar orbit but only slightly out of phase by an hour. It is possible to maneuver SMAP into the ideal orbit or launch a new SMAP. The 4 satellites orbit in formation in the exact same orbit with only a few minutes spacing between the satellites. By placing the sensor satellites a few minutes behind the Rainmaker, the sensor satellites can observe the cloud seeding by the Rainmaker ahead. The whole D-Train weighs less than 10 tons, including the SMAP, hence can easily fit the constraints of a medium-lift launch vehicle like the Falcon 9. When NASA lost its A-Train lead satellite, the Orbiting Carbon Observatory (OCO), in a launch failure, they were able to just build OCO-2 and put it in a constellation in place of OCO. This is an example of how distributing functions across satellites will allow for redundancy. If more satellites or instruments are needed, they can be launched additionally and put into a similar orbit. Like other satellites, the constellation would communicate with the ground via UHF or VHF bands when in line of sight of the ground station. The entire system will automatically communicate with the ground station, where the process of cloud seeding can be eventually automated and optimized with machine learning. Based on past data, the system can learn to predict droughts and automatically prepare cloud seeding configurations like laser direction and power. A project like this can be a collaboration between many countries, for example ASEAN, with a different country designing a different part of the system. Together, they can help Vietnam protect their people from drought.